Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's Advanced DBA meeting. Our original speaker wasn't able to make it. Something came up, but fortunately, I actually have a talk that's kind of similar in concept to the original plan. So we'll do a quick shift. I'll give this talk, and we are going to speak about revitalizing the SQL Server code base. So the title of the talk is Teaching Old Dogs New Tricks. But in this case, you folks, chat, you're not the old dogs. Your SQL Server is. So let's talk a little bit more about that. I'm going to decrease my ego slightly and get started. So my name is Kevin Feasel, in case you haven't met me before, or if you're new here. I am the president of the Triangle Area SQL Server Users Group. We're based out of the Raleigh-Durham, North Carolina area, or the Research Triangle area, and been doing this for a hot minute. So welcome in. I personally am a data platform MVP. I live in Durham, and I do a little bit of work on the data science side, as well as a bit of consulting. With that, I think it's enough about me. Let's talk about the talk. So the motivation here, why are we talking about this? Well, it stems from the fact, and I'm actually going to jump to the top here, even though I'm cut off at the chest level, it's a little easier to see the slide. But databases tend to last a lot longer than applications do. We change web applications pretty frequently, and you pick up the new JavaScript of the month framework and decide, well, we're going to rebuild our web app. But that database that's been sitting around since the company was founded, that thing is still going to be there like 15 years from now. For example, I've worked with databases that are, at this point, going on 20 years old, and still they have changed significantly over that 20-year period, but I'll bet you there's still some code that was originally written 20 years ago, and in your cases, you may have situations like that as well. Well, SQL Server has changed a lot over even the past decade, and there may be better ways to solve problems than what you had to use when you originally wrote that code, or when whoever owned that database at that point in time wrote that code. So our goal here is to bring a bit of vitality back to those old databases. We're going to spruce it up. I'll go and show you a whole lot of examples of how you can adjust to modern T-SQL. I'll lay out a few ground rules here. Basically, I gotta jump up top again, but we'll focus solely on T-SQL improvements. I'm not going to talk about integration services, analysis services, reporting services, ML services. I'm not going to talk about in-memory OLTP, query store, cardinality estimator changes, IQP. I'm not going to talk about Polybase or any of these other additional services. We're going to focus strictly on T-SQL as part of the SQL Server database engine. And I am going to start with SQL Server 2012 and then move forward version by version. Speaking of additions, if you're running SQL Server 2016 SP1 or later, you don't have to think about addition at all. All this stuff will be available in all editions of SQL Server. If we're running 2012 and 2014, I don't think I have anything that is explicitly Enterprise Edition. So we'll keep that in mind, though, as we're moving along. So we will start in 2012. We have 6 separate versions of SQL Server to cover. And as a quick reminder, I won't even cover column store indexes. I like column store indexes, though actually not in 2012. In SQL Server 2012, they were read-only, and they weren't that good. I'm also not going to talk about availability groups. Great functionality, not the topic of discussion. And by the way, if you have any questions, please enter them into chat. I will have chat actually right there, so I may be looking over that way on occasion. I'm going to try to stay a little bit face forward so that you can hear me most clearly through the microphone, because as I start leaning over that way, it will cut out just a tiny bit. So let me see how disciplined I can stay throughout this talk. But see, I'm already tilting. I'm already on tilt. But let's talk about these demos, and I'll bump up the size just a tiny bit. So let's talk first about something that was in SQL Server 2008. So I'm even cheating a little bit, but If I wanted to get the current day, I would have to use this combination of functionality, the combination of date add and date diff. And the thing is, if you ever have to explain to a new developer or to a new database engineer or whoever, how do I get the current date, just the date part, from something like get UTC date or get date? Well, you show them this. And you say, oh, it's easy. Date add, day, comma, 0, comma, date diff, day to comma, 0, comma, get UTC date. And they ask, what does this mean? It's a little complicated for what it's doing. Well, to give you an idea, we start from the beginning of time. And in case you were curious, the beginning of time is, of course, January 1st of 1900. Nothing happened before January 1st of 1900. So that is 0.0 in the world history. And we're going to add the number of days between the beginning of time and today to the beginning of time. So because we're adding days, it's going to stop at the day level. It won't include any hours, minutes, or seconds. And for that reason, we can run this and get August 13th of 2024, which happens to be today. Well, as of SQL Server 2008, we have the ability to cast get UTC date as a date type. So we can cast as a date type. We can cast as time if you needed just the time element of this. And you'll notice that the results are almost exactly the same. The reason I have to say almost is this is in fact of type date and this is of type date time. So you notice that there is still a time component. At this point, pretty much every application framework is going to be able to support dates and date times. If we went back to the year 2009, right after SQL Server 2008 was released and we had this new data type, there may have been some applications that couldn't support it very well. We're 15 years in the future. Your application is going to be able to support the date type pretty easily. But I did want to make mention of the slight data type difference just to make sure that, that's clear. Okay. Now we're going to get to real examples because that was even cheating. That was available in SQL Server 2008. 2012, first thing I want to talk about is concatenation. Prior to SQL Server 2012, we had to concatenate using the plus operator. So this is our concatenation operator in T-SQL. And if you have null and concatenation, you're going to get null. So anything plus null is null. Well, that means if I don't want null to be there, I have to use is null or coalesce. So here, if this is null, we're going to change it to an empty string. If I have a numeric value and a string value, this numeric value, we need to upcast it to a string. We need to make it a string so that we don't try to cast this string as numeric because that would give us an error. Same thing with a float. And so if I run this, I will in fact get a result. But in 2012, we got access to the concatenate function. Concat. With concat, I just have a comma separated list of all of the things I want to concatenate together. Notice that it will handle nulls. It will handle different data types. So floating point, integer, whatever data type this really is, it all works. And if I run, these two will be, as I scroll down just a tiny bit, exactly the same. I suppose I could also stretch this up so that we can confirm these are exactly the same result. So concat, very useful for combining together without having to throw in a bunch of checks or cast operations or whatever. Just take it as it is, get out a string. The third thing that I want to talk about is running totals. Prior to SQL Server 2012, we had 3 ways of performing a running total calculation. And just to give you an idea, I've got a table here, sales.orders, and I'm going to join to order details, and I'm going to focus on 2 specific orders. So if I run this query, we get back some information on product ID, unit prices, quantities, and the order IDs. And what I would ideally like to be able to do is get a running total of maybe like unit price times quantity. Well, as I mentioned, there were 3 ways to do that prior to SQL Server 2012. the slow way, the slower way, and the bad way. The fast but technically bad way. Let me show you the slow way. A cursor. Cursors were actually the fastest officially supported mechanism for calculating a running total prior to SQL Server 2012. Now, I'm not going to talk through all of the code involved in creating this cursor, but I will point out we start on line 64. So keep that in mind. We're going to create the table. So we need a temp table. We're going to add a primary key constraint for performance reasons. We'll load that temp table up, and then our cursor's really beginning right here. But I do start counting at 64 because all of this stuff is necessary for the cursor for performance reasons. The cursor itself will be a local static read-only, forward-only cursor because of course it is. I'm sure that everybody here has a strong understanding of what all of the cursor properties mean. I'm sure that I have a strong understanding of what all of the cursor properties mean, by which what I mean is I try to avoid cursors whenever possible, like the rest of the sane people. And I gotta check right now to see if Anders is in the audience. Okay, Anders isn't here, so he won't give me grief about how glorious and beautiful cursors are. But if somebody else would like to give me grief that cursors are glorious and beautiful, you're welcome to. I doubt many people will take me up though. So we create our cursor, we're iterating through, and if the current order ID matches, then we'll do one thing. Basically, we'll add the line total to the running total. The line total, by the way, as I noted, was unit price times quantity. If the order IDs are different, then we're going to reset the running total. So we'll set it to the new line. Basically, we're going to go through all of the orders for the first order line. Then we'll reset. We'll do all the orders for the next order line, reset, do all the next orders, et cetera, et cetera. I will sit in on for Anders. Cursors are fine if you use them correctly. Well, that's a big if. So we update our table, we set running total for our order ID, for our product ID, and then we just keep iterating through. Close and deallocate the cursor, get our results, drop the temp table. So it is roughly 80 lines of code. Now, as I run this is a very small table, so it's going to be fast. It does work. We do have our line, we have the running total, it increases, and then we reset for the next order ID. So bravo, it does work. And in fairness to Solomon's attempt at filling in for Anders as King Cursor Troll, it was, like I mentioned, the fastest officially approved way of getting a running total at that point in time. There was an alternative approach. See, when we talk about cursors, we talk about, well, you don't really want a cursor. You want, in SQL Server, in T-SQL, really you want set-based operations. You want things that will work on the entire set of information at once. And those are typically faster. And so your application developer would look at the cursor and say, I can rewrite this and say sales.order details left outer join on itself based on order ID, and the product ID is less than or equal to the current product ID. So that way, I can have my running total iterating over the product IDs and then renew for each order ID. So the problem is, this is the fact that we have an inequality operator in our join clause will cause this not really to be a set-based operation. It will actually cause SQL Server to work harder to give you the results than the cursor-based version. There will be more iterations, more loops through the data than the cursor-based version requires. You'll notice this especially as the data set gets larger. With just a few rows, you're not going to notice it. But if you talk about hundreds of thousands of rows, you absolutely will notice the difference. The cursor-based version will be faster. Now, the results will still be the same. The numbers are still the same. And there was a third option. It used to be called the quirky update method. This is one that literally was never supported. It actually relied on an unsupported quirk in the way that clustered indexes got built and maintained on temporary tables. And the downside to it was that even though it was really, really fast, it was the fastest mechanism prior to SQL Server 2012, but any update, any patch of SQL Server could have broken that functionality because that functionality was undocumented. It was not official that this is how the table operations will work. It just happened to be the case. So you always sat in fear that the next version of SQL Server or the next cumulative update or service pack would break this code. That's why I don't even show it here. There's zero reason if you're running SQL Server 2012 or later to use the quirky update at any point because we have a better alternative, something that is better than the cursor, that is better than the self join, that is better even than the quirky update in terms of performance. And that is a window function. So if you're curious about window functions, I actually have an entire talk on window functions, and I will drop the link in chat here in case you're interested. I may even have videos on it, but nonetheless, we'll talk just as much as we need to about this. Basically, a window function, I know this is one because it has the over clause after some function. In this case, this is an aggregate window function. There were some window functions that you could use prior to 2012. Those were rank, row number, dense rank, and intile. And so they were ordinal window functions. Aggregate window functions were introduced in 2012, and here I could get the sum of quantity times unit price over a particular window. Well, my window is going to partition by order ID. So you can think of it as each particular window or each filter of the window is per order ID. So we reset every time we have a new order ID. We sort this thing by the product ID, and our frame of interest is all rows between unbounded preceding, that is the very beginning of the set, and the current row. And if I do that, then in one pass through of the data, I get my results with my running totals. So as the record sizes, as number of rows increases, this thing still scales really well. It is one scan of the data. The cursor approach is more scans of the data and more seeks of the data. The self join is just a horrible mess. Now, speaking of window functions, 2012 introduced a lot of quality window functions, including these window functions that deal with, say, the frame of view. So we get lag and lead, which are two of this class of window function. The other two were first row and last row. The idea of lag is I'm going to look at the prior order ID if I partition this by customer ID. So in other words, for a customer, we look at their current order. So we have the order ID for that customer. And then we can also look at the prior order. Or if we use the second parameter of lag, I can specify how many records back, how many rows back do I want to look. So here I'll look back one row, which actually is exactly the same as lag without a parameter. Here I'll look back at 2 rows. With lead, I'm looking ahead to the next row. So the next row, the next 1 row, the next 2 rows. And if I run this, I can see here's my order ID, my employee ID, and my prior order was 10,952. My 2 orders ago was 10,835. So if I look at this record, 10,952, its next order is 11,011, which is that one right there. So we can see how it fits together. We have our priors, we have our next orders. Now you could do this prior to 2012, but here is the equivalent of lag, single record lag. We have sales.orders and we outer apply P1. So P1 is sales.orders where customer ID is a match and the order ID is less than our current order ID. So for each order, go find me the prior order. If I wanted to do a lag 2 rows back, what I needed to do was this, outer apply, and I'm going to jump to the inside here. So from sales.orders, I needed to get the row number partitioned by customer ID, ordered by order ID. So that is row num. And I have the order ID itself. We're going to sort by order ID descending because I need to get the top 2. And then I need to get the number where row num is 2. So basically, if I wanted to do lag 3, then I have to change that to 3 and 3, etc. A lot more code, not as good of performance. This will not perform nearly as well. Lag is one scan of the data. This, if I show the execution plan, we have a scan of orders. If I scroll down, we have a seek of orders. If I scroll down, we have a seek of orders. So we have 3 separate passes through of this orders data, 1 scan, 2 seeks, 2 sets of nested loop joins. By contrast, the lag and lead, noting that I have more operations in here, my query plan it's long, but I have 1 scan of the data and then segment sequence compute. So we've got window spools, we've got many different views of the data that just have to do with the fact that I've got a lot of different lags and leads in here. Nonetheless, if I were to do a performance comparison, you're probably not going to see too much of a difference just because data sizes are so small. But over a longer frame, over a larger amount of data, this is going to perform better than this option. And it's also going to be a lot easier for a human to read. Okay. Another thing, this has been around for 12 years, and the number of database people who are not familiar with the try series of functions is astounding. And so if you're not familiar with it, this is actually really, really helpful. Cast has been around for decades in T-SQL. If I cast the number 12 as a decimal, I get 12.00. If I cast the string 12 as a decimal, I get 12.00. But if I cast something that is not a decimal value or is not convertible to a decimal, I get an error. Message 8114. Error converting data type varchar to numeric in this case. If I slap on the word try and I run this again, I'll get back a null instead of an error. So, by the way, this also works for try convert. Works exactly the same. And I should note that try cast versus cast, try convert versus convert, performance profile is so close that I don't think you're ever going to notice a difference. Even if you're talking tens of millions or hundreds of millions of rows, I don't think you're going to see a millisecond's worth of difference. Because I have tried this on millions and tens of millions of rows, and basically the differences were noise. So, extremely helpful. And this is particularly useful for things like ETL jobs where I'm trying to load a large number of records and I haven't yet been able to perform quality checks. So I haven't maybe been able to check to see if the data type is correct from our input data that's a flat file, but I want to still load the data. I don't want it to fail on row 980,000 out of a million. I want it to load the million rows and then have some indicator that, oh, this was missing, this was incorrect. So my developers or my business analysts or whoever can go back into the data and figure out why is this missing. So Mark asks, do you see less use of convert statements moving to cast statements? I think convert versus cast, outside of dealing specifically with date time, where you get some additional options with convert versus cast is just what did you grow up with, essentially. I use cast more often than convert, but that's just I prefer cast. Just it's quicker for me to remember. Functionally, they're going to perform essentially the same. If I remember right, there may be some slight difference in performance under specific scenarios, but for any reasonable use case, I'm not going to note. I've not noticed a difference between cast and convert. Again, the major difference is date time. Now, if we throw parse into the mix, there is a try parse. Try parse is actually really useful, but it's a lot slower because try parse uses the CLR. Same thing with the parse function. I believe cast becomes convert internally based on viewing various execution plans. I think you are correct. I think if I remember right, there's some weird exception that has to do. I thought it had to do with some date operation, but um, in general, I think you're right, Solomon, and you could be totally right. I'm hedging my bet just because I have a very vague, tickling recollection in the back of my head about one scenario where convert and cast, they don't behave differently, but the performance profile is slightly different. Also, convert has format options for var binary. Okay, yeah, I've dealt with var binary so infrequently with convert, but you're right. I have had to do that. I think it was actually with some CLR oddities. Maybe some other data types have convert style options. I think it's just date time and var binary. But again, I'm doing a whole bunch of I thinks and I believes as opposed to I knows because, well, I'd have to go dig through the docs to tell you for sure. And I am willing to admit here I could possibly be wrong. Please don't tell my wife. Okay. Last thing about try parse. So try parse allows us to use regions. So because this is using .NET under the covers, I can take advantage of .NET style regions like English US. So 01/13/2019, that would be the 13th of January 2019. So January 13th in the US. Well, if I use that same exact pattern and I say this is French, this would be the first day of the 13th month. So the 1st of Smarch, France doesn't have Smarch. They traded for the metric calendar, so they only get 10 months in a year. And so we get our extra month and they don't. All right, fetch and offset. We're introduced in SQL 2012. Just to give you an idea, this is for paging. And actually, I will admit, I'm not the biggest fan of fetch and offset simply because of the performance profile. If you're a frequent Shop Talk viewer, we did talk about this. Actually, I showed this exact demo in Shop Talk a few weeks ago. But let's talk about it now. Suppose you have a website, and that website is going to display your data, but you've got more data in the database than you want the website to display at a time. You don't want to show a million records. You want to show 30 records and then have a next page button, or start on page 12 and show me the records on that page. So sort of like a Google search back when Google searches actually got you back results you wanted. In this case, we'll start with a page size. Our page will be 10, and we'll start on page number 4. So in other words, we are going to get back rows 30 through 39, or excuse me, 31 through 40. That's what we'll get because we're going to start pages of 10. So first page will be 1 through 10, second will be 11 through 20, third will be 21 through 30, fourth page will be 31 through 40. There are a couple of approaches to this. One of them, the nested top approach. All right. Inside of here, sales.orders, where employee ID is 6, I need to get the top 40, so 10 times 4 records, from which I will then grab the top 10 records sorted by order ID descending. This does work, but the problem is you're going to have to scan through 40 records. So I could actually reverse, scan through 40 records in order to get just the 10 that you want. Not great performance. And commenting here, I have a legacy job, haven't dug into it, that fails with a possible truncate error. Rerun it and it works okay. It's weird. Maybe TriStar would fix it. That would at least give you nulls in your fields. So if you know what the original value is and you know what you're trying to convert it into, truncation may still be a problem. Because the try convert, like if I can actually gen up an example right here. It's the nice thing about what we're doing. So if I say in varchar 2, I actually will do the convert down. Okay, so it will automatically truncate down here in this try cast, this explicit cast. So maybe. Solomon being helpful. I'm going to read this. Solomon is very helpful. Even if he is also pedantic, that is totally fair. There are also convert styles for float, real money, small money, and XML. Okay, float, real money, and small money. I'm actually surprised decimal's not in there, whereas float is. But I will. Oh, it would be probably things around like number of spots a floating point. Okay, and XML. XML is not a real data type. Missouri is not a real state. And for the rest of those, yeah, okay, that's fair. That's fair. So there is a difference between convert and cast for people who use those data types. If you just make integers and in varchar for everything, then yeah, no worries. I have a lot of small money. Okay, so that was approach number one, the nested tops. The problem with that approach, again, is you have to scan through all of the records up to that point to get the small subset at the very end. And 40 records is not bad, but imagine it's 130,000 records and you want to get the last page. You have to scan through all but the last 10 rows, or actually all the rows, and then just to return back the 10 rows. So as you go further, increase in page number, performance will get worse. Page 1 will be fast. Page 2 will be ever so slightly slower and slower and slower and slower until people notice the difference. Second approach. I'm calling it the prior key approach. The idea is the application needs to know where to start. So it got up to key ID 10599, and we're going to get the next 10 records after that. The advantage to it is essentially flat in terms of performance quality if you have appropriate indexing. So if we have an index on employee ID and order ID, we can guarantee I'm going to seek and get 10 rows. So it doesn't have to scan through the pages in order to find those 10 rows. It grabs the 10 that it needs and returns back however many you need. Now, there are a couple of problems with this approach. Number one, your application has to be smart enough to know what starting key. Number two, you have to have a starting key. And this shouldn't be, or it should be unique. It should not be something that you can have duplicates of, because it is possible that if you have maybe a duplicate on row 10, so 10 and 11 should both show up, but they don't, then the next time you run, you may actually skip the row 11 if the ordering changes. So if you have a non-deterministic order and you have the possibility of duplication on your key value, this may not work well. But if you're doing something like, this is my identity integer, shouldn't be a problem. Now, the other issue that you can run into here is if you have an application that is regularly inserting in the middle. So with an identity integer, this isn't necessarily a problem. But if you have updates that are happening to older data and you need to express that, or you have new rows that get inserted, let's say this isn't an identity, maybe it's a date time and you have some data that got inserted late, you might miss results in your grid. So there are possible risks depending on how you construct this. Performance-wise, it's going to be the best performer, but you just have to keep that in mind as you're going through. In 2012, we got offset and fetch. So offset and fetch, the syntax of this is nicer than the nested top approach. The performance is the same as the nested top approach. You are essentially needing to scan through your data until you get however many records you need, so 10 times 4, and then give me back just the last 10 rows. So performance-wise, this is not going to be an improvement. Syntax-wise, it is arguably easier to read. But that said, if I have a performance important operation, I'm still going to implement this prior key approach style. All right, so that was 2012. 2012, it had a lot of stuff for us in terms of T-SQL code improvements. And to this day, I think there's a fairly large subset of database professionals in the SQL Server space who never learned about some of this stuff because that was also the year that licensing changed for SQL Server. So there were a lot of companies that stayed on 2008 R2 for the better part of a decade, and then eventually moved up to like 2016 or 2017 because they had to, because 2008 R2 had gone so far out of support. So I believe some fair number of database professionals just didn't learn about some of these concepts because they skipped that version. Now let's talk 2014. 2014 had a new cardinality estimator come had in-memory OLTP, had delayed durability, updatable column store indexes, starting to get useful. Parallelizable select into. None of that stuff is what we're going to care about. Instead, there was one thing that came accidentally or incidentally with in-memory OLTP that's going to be of interest to us tonight, and that is inline index definitions. Prior to SQL Server 2014, you could not define an index inside of your create table statement. It had to be outside of the create table statement. Create index, blah, blah, blah. But in-memory OLTP necessitated this change because you could not modify the table structure of a memory optimized table after you created it. You would have to drop and recreate that table if you wanted to make a change. Well, if you needed to add an index to the table, which you probably would, then it wouldn't help to drop and recreate if you had no capacity to add an index at create time. So they gave this capacity. It is available for all tables, not just memory optimized tables. This is just a regular temp table. You could do the same thing with any other type of table, memory optimized or not. And so it's neat. It's a small thing, but if you have deployment scripts and you want to make sure that your indexes go out along with your tables, it's kind of useful. Can you add more than one index in the create? You absolutely can. So we could say like, 2 index. So maybe do something like that. Drop table. We're going to drop test table. We're going to run this again, and we get 2 indexes. So yeah, you can have as many indexes as you want in the create statement here. We just separate lines with commas. We could also define the clustered index. So I am using the implicit definition, or implicitly indicating this is on test ID versus explicitly defining a separate clustered index as a separate line here. So we could do that as well. I'm just taking advantage of the fact that I can also say constraint PK test table primary key clustered, and it will create a clustered index that is also the primary key. Call that thing PK test table, and it is based off of test ID. So all of that is capable within the realm of our table definition. So small thing, but pretty neat. And well, if you were using 2014 and didn't take advantage of those other features that I talked about, that was about all you were getting in terms of T-SQL changes. But 2016, we have a few new things. There was a lot in this release. Query store, adaptive query processing, temporal tables, Polybase version 1, always encrypted, row-level security, dynamic data masking, SQL Server R services. We're not going to talk about any of that. Much of it is cool. I have talks on some of this stuff, but this is a little bit outside of our scope. So instead, let's narrow it down and let's talk about what we are going to talk about. First, this is a small life changer. I remember, Pepperidge Farms remembers, having to deal with create and alter statements for procedures. If you look at the definition of Atom Mechanics who is active, actually I can bring that up right now. So I'm going to vamp. Maybe I'll vamp. But I'll bring up the GitHub repo for it, and we're going to look at the definition of SP who is active, which a lot of people probably have never done. But at the very start, what Atom does is, if not exists, select star from information schema.routines, where the routine name is SP who is active. Now, I would have done sys.procedures, but this also works. It works just as well. Execute, create procedure SP who is active as a stub, and then his procedure is just an alter statement. So Atom has a create statement if you need it, and then immediately an alteration. The benefit behind this is you can rerun the script. It is idempotent. You run it 2 times, 3 times, 4 times, you will get the same results, the same end state. The problem is you have to write that block. You have to do that for every single one of your stored procedures, which, yeah, you can do that. I mean, we did that before, but it kind of sucks. And in 2016, we got the ability to say create or alter procedure because the database engine will know. It'll know because I try to create a procedure. It'll give me an error that says, hey, that procedure exists. So then I say, if you know that the procedure exists, why not just modify the procedure and allow me to just have one bit of code that does both, which is what we do here. So I will create a procedure called dbo.execute something, and it'll take in an input parameter. We don't really care what it's doing, just that it exists. And by the way, I want to run it many times. It'll work. So that means it could be part of a CI/CD operation where I could deploy this thing out. This could be a deployment script and just go out constantly, hundreds of times. It'll still work. It's not going to break the second time. And creator alter is the greatest thing since sliced bread. Yeah, it is. It is amazingly good. Execute something. We executed something. Now I could change this. Let's say instead of an integer parameter, I have an invarchar 50. I could change that. We don't have to worry about the details of the inputs for the parameter. I don't have to worry about application code changes because we're not talking about that today. Just indicating that I can make this change. Now we also have drop if exists. I wish more things had drop if exists, but we can drop procedures, we can drop tables, we can drop views. We could also drop functions, as I recall. Let me double check that. Oh yeah, okay, because it's a procedure. Execute something functional. Okay, so we can drop a procedure, a function, a table, a view. What you cannot drop, if exists, is a user-defined table type. You do actually have to check if the table type exists and then drop it explicitly. So that capability is for procedures, functions, tables, and views. And I'm actually going to save that, and that'll be part of future deliveries of this where I will indicate explicitly functions. Usually I ignore functions because functions are painful, but I will make mention of this. String split. String splitting, prior to SQL Server 2016, there were a few techniques for it. In most every database I've ever seen, there is always somebody who has created a function to split strings. And that function to split strings was probably some code that somebody else copied from the internet, that somebody else copied from somebody else, that copied it from somebody else. And eventually, it ends up in a database, and it ends up as a critical part of a company's infrastructure, because that's how this always works out. And then somebody like me comes in, they say, oh my gosh, this query is so slow. Why is it so slow? And I notice that you're splitting your string on very large amounts of data, and that this is a user-defined function that is really slow. So in the SQL community, specifically the SQL Server Central community, there was a bit of a code golf exercise a while back about how do you make the fastest string splitter. And people tried a variety of different techniques. You have those user-defined functions, you have tally tables, you have explicitly created tally tables, you have common table expression tally tables. In case you're not familiar, a tally table is just a numbers table. It's literally one column and one row for each number in a sequence. So it gives you a sequence of numbers and allows you to do some really neat things with data. The fastest approach was CLR, so using the CLR to perform string splitting. And so, you have these different approaches. In 2016, Microsoft introduced string split. And the benefit behind this is tally tables are really great, but they are difficult to understand. Now, if you want to learn more about tally tables, I have a talk. On the topic, but it is actually obsolete. So I get to show off my this is obsolete image. Nonetheless, I do probably still have the slides up in case you're curious. I may even have demo code. Oh wow, it was so old that it was a zip file. Tells you the last time I gave this talk was probably 6-7 years ago. But even though it's obsolete, if you're interested in tally tables, it is still going to give useful information. It's not like that's changed in SQL Server until we get to sequences. But I don't really talk about sequences here. Okay, string split. We have some text, and I want to split it. And in SQL Server 2016, our string split function is going to be much faster than a user-defined function. My recollection is that it's a little slower than the fastest CLR techniques, but that it was at least on par with tally tables. That's recollection. I probably should dig up the actual performance characteristics because I could be off base. But we have our string and we have our separator. Our separator will be a comma, and we're going to get back, if I run this, 1 record per split element. Now, this came out with 2016, and there was a little bit of controversy in the community. A couple reasons. One is the results coming back here. Yes, they are, in fact, the same as what we see in our input string, but there's no guarantee, as I recall, that this would be in the same order. Parallelism could affect the order of this. Secondly, there's no way to keep this in order if I have something that forces it out of order. So there's no way for me to tell that 1, 2, 3 was the first element, 4, 5, 6 was the second element, etc. So if I need that kind of ordering, I don't have it in SQL Server 2016. Spoilers. But still a very useful function that's just built in and obviates the need for those user-defined, really slow string splitting functions. This next one, kind of like try cast, try convert. This is something that a lot of database developers and database administrators didn't really know about. It snuck in the background. Format message. Format message is technically for handling error messages so that you can have a professional looking error message, essentially. But there's no need for it to be just on an error message. You could have a nice looking output and use parameterization to say employee, some numeric value, received order, numeric value, on string value, going to string, and then pass in your parameters. So instead of having concat and then saying like concat employee space, comma, o.empid, comma, space, yada, yada, just fill in the parameters like you would a printf statement or a similar statement in Python, F#, C#, whatever, where we have filled in parameters. And I can do this for every record in the orders table. So we see employee 6 received order this on this date going to Kirkland. By the way, there is no parameter here for date, so I actually need to use a string, and I need to convert my dates to a string in some particular format. I just happened to choose this format because it was nice. It's technically the most appropriate date format, but I prefer having hyphens in there. So that was format message. Again, something that came out of 2016, maybe a little unexpected, but still kind of neat. When it comes to 2017, the big release was SQL Server on Linux and also SQL Server on containers. The second biggest thing that came out of this was support for Python in SQL Server machine learning services. Aside from that, there were a couple of things: adaptive query processing updates, trying to make more intelligent queries, distributed availability groups, graph database support. That's all I'm going to talk about with any of those. So instead, let's go and see what we are going to talk about. First, concat with a separator. I had an example before of this is a string and we've got some concatenation. But what if I want to have a separator? What if I want to have something breaking up each of these segments? I could, if I wanted this triple pipe, space, I could do, something like this and manually insert it for each one of the elements. Or I can use concat with WS with separator, put the separator first, and then all of the things that I want to separate after that. So now we have, this is a string, triple pipes, the number 12. So you see here, triple pipes. And if I extend it out a little bit further, we're going to have more information, but kind of get the idea of our elements. Interestingly, you may notice this is a string. We have triple pipes after that, but there is no triple pipes after null. So if I do change this to like empty string, funny thing is, this is the first time that I'm noticing that, but nulls don't output a separator value. So kind of interesting. Just pick that up. Trim. Prior to SQL Server 2017, we had a couple of functions, ltrim and rtrim. So we have a string. Now I've got a string here just to let you know I'm highlighting this, and all of the dots, you might have a little bit of difficulty seeing the gray dots, but these are spaces. If I select the data length of this is in varchar 100, data length is 124. There are actually 62 total characters in here. Then I'm going to do ltrim rtrim. Ltrim will remove all of the spaces prior to the first non-space character. Rtrim will remove all of the spaces after the last non-space character. And if I run that, I'm down to 52 bytes is the data length. So in this case, 26 characters. I got rid of a lot of spaces. That's kind of neat. I mean, we've been able to do that for a long time, but we have ltrim and rtrim. You can do trim. So one word, it's a small change, but slight quality of life improvement, and gives you back, as we can see here, the same results. Okay, kind of neat, but what about tabs? I now have 3 tab stops, and then this is my string, and then I have some spaces. I have a couple of tab stops here, spaces, tab spot, couple spaces. If I run this, sum string, the ltrim, rtrim, and the trim version, let's take a quick peek at all 3 of those. 120 is the string length here. We're down to 116. Notice that it still has all of those spaces at the beginning. All it got rid of were 2 spaces at the end. When I said space for ltrim and rtrim, literally the space ASCII character or Unicode character, it is not any white space. It does not include tabs. It does not include line feeds, new lines, vertical tabs, the line separator, special character in ASCII. Does not include any of those except for good old-fashioned space on the space bar. However, we can use trim and say, well, what if I include as an input parameter trim plus char9. Char9, by the way, is the character value for a regular tab. So, I need to get just this one. So we went from 120 data length to 116 bytes data length and down to 52 because I am trimming both spaces and tabs. But spaces aren't the only thing you can trim. So here I've got another string that starts with OK, and then this is the real string, OK. And I want to trim KO from the string. So what we get is, this is the real string, OK? This is not a word. This is just individual characters. Each individual character that we will remove. And what that means is that I will remove anything that is an O or a K until I get to the first thing that is neither an O nor a K. And then over here, I'll do the same thing from the right-hand side. So that's why we have question mark and then OK. So we don't get rid of that OK because we have a character other than an O or a K in between. So that's what trim is doing. It is trimming individual characters. Basically, think of it as looping through and saying, are you one of these characters? If so, goodbye. And if not, break. Another thing that we got out of 2017 is string aggregation. String aggregation is the first um, type of its class. So in SQL Server, we have window functions, and talked a little bit about that. Window functions will have an over clause, and they have possible inputs of partition by, order by, and frame. The other type of operation here, this is called I'm looking for the name just to make sure that it is a nested set operation, but it's an ordered set operation, excuse me. So ordered set operations are just a tiny bit different from window functions. I'm going to create a table. We have states and regions. Now, mind you, states here includes District of Columbia. It includes Puerto Rico. It includes the Virgin Islands. I pulled this right out of Wide World Importers. But we've got our table with states. Each state has a code, and then it has a sales territory. And we're going to query this, and we'll see that Alabama's in the southeast, Alaska's in the far west, et cetera, et cetera. Now, what I want to know is, for each sales territory, give me a comma-separated set of values for each state in there. If we were using anything prior to SQL Server 2017, the solution to that is, of course, for XML path and the stuff function, which just makes intuitive sense, I'm sure. Like when you bring in a new developer and you say, yeah, this is how you perform a concatenation operation in T-SQL, they'll say, oh, duh, of course. I use for XML path and I use the stuff function. I have these parameters for it. How could I not have thought of that? This is counterintuitive. This takes a while to explain. We don't really use the stuff function for very much in T-SQL. For XML path, this is a quirk of how the XML operation works. This does work. It works well, and it gives you the results that we're looking for. But I would argue this is not very maintainable. This is harder for a new person to understand, and there's a risk of a little bit of cargo culting. By contrast, here's the string ag version. Sales territory and string aggregate the sales province codes, separating them with a comma from states. And because string ag is an aggregation function, we need to group by sales territory. If I run this, I do get back my results. Now, notice that they come in any particular ordering. So if I say, I would like to see these in alphabetical order, there's a property on an ordered set function within group. So I have string ag within the group of sales territory. We are going to order it by state province code, and that will give me the proper straightforward ordering. So here I can use, in just a couple of lines of code, something that is a straightforward function to look up. And, within group is uncommon T-SQL syntax. There are relatively few operations that use it, but it's still intuitive enough, especially compared to this that we've kind of forced ourselves to memorize or to learn the right way to copy paste. All right, 2019. 2019, another release of SQL Server. Quite a few things going on: intelligent query processing, memory optimized TempDB metadata, accelerated database recovery, batch mode on row store operations, Polybase going out to ODBC, support for UTF-8, ML services supporting Java. Who cares about that stuff? No, we care about something else. What do we care about? We care about approximate count distinct. Okay, a lot of people here probably don't care that much about approximate count distinct, but let me try to change your mind. So approximate count distinct, I'm going to create a table, and I'm going to have 40 million rows in that table. And while I'm creating that table, now it's going to take just a couple moments, but what I want to get is the count of distinct values of some int column. So some int column is based off of a checksum of new ID. I'm probably not going to have that many duplicates, but I will have some duplicates. If I run count distinct, this is going to be a full scan through the entire table. And I don't really have any way of making this faster, to be honest, because I need to scan through the whole table. Looks like it did finish loading those rows, so I can run this. And it's going to take a moment. So it took If I pop up myself to the top, we can see that it took somewhere around 2 seconds to finish. Now, I could set statistics time on and give you a clearer idea, which maybe I'll do that in a moment. But we can see 39.8 million unique values. So we do have some duplication, but most of these are unique. Approximate count distinct uses an algorithm known as hyperlog-log. This is a technique that is guaranteed to get you within 2.3% of the correct value and will be much faster. So by running this, if I pop myself up to the top, you'll notice that it took less than a second and gave me actually more results than I have rows in the table, which you might say, oh my gosh, that's wrong. Technically, it is wrong, yes. But the thing is, it's wrong, but it's stable. The thing of it is, when you are dealing with large numbers like this, in many cases, we don't necessarily care about the exact number. We care about the order of magnitude. We care about approximately. If I told you that there were 40.1 million unique values in large table versus 39.8 million unique values in large table, there are some circumstances in which that makes a huge difference. In most circumstances, it does not make a huge difference. We're within a couple percentage points. We get an idea. There are a pretty good number of unique values. If I were to show them on a page, I would not want to display everything on one page. So if I wanted to give people a rough idea, like if I said this project is going to cost $39.8 million or $40.1 million, at that level, until we start talking about writing checks, does it matter that much? Probably not. Unless we are performing actual budget optimization or accounting work. To give somebody an idea that it's going to cost you this much money or slightly different number, not a big difference. So approximate count distinct may not be something you write every day, but if you are doing data analysis, it's actually pretty useful. Number 2, this is actually really nice. The worst error message ever, message 2628. And I'll bet you there are at least 3 people in chat who can tell me right offhand what message 2628 is. And they're probably either clawing their eyes out or glad that they've got SQL Server 2019 or later. So what is message 2628, you might ask? Well, let's create a table. I'm going to create a table, and I've got a column here, some string that is in varchar 10. We're going to insert some rows into the table. And hey, everything looked great. We're going to ship it, send it to production. And then some yokel inserts in test 3, but this one's a little bit long for us. And so we try to insert in here, and we get message 2628. String or binary data would be truncated. Now, prior to SQL Server 2019, that was the entire error message. What data would be truncated? Don't know. How big was that data? No idea. How would I figure out what that thing was? I don't know. SQL Server would be completely unhelpful in telling you what was the thing that it was trying to insert, but actually was going to be truncated. As of 2019, we now know the table, we know the column, we know the truncated value. It actually cuts off at test 3 but because it cuts off at 10 characters. So pretty nice. Also, this works for updates. I try to update and it says, hey, this up that, and then it would be too long. So we at least get the A value, and then we can go fix that in our source system. Now, the pain point is if I have to do this 500 times because there are 500 such values, and I have to run the ETL operation and wait for it to fail on the next element. That's a pain point. And that would be where, all right, let's talk about a different way of performing ETL and trying to more explicitly reshape this data before, or maybe like load it into the table as a larger in varchar value, and then try to winnow it down to what the value should be. But still, very helpful, extremely good fix of an error message that was the bane of T-SQL developers' existence for literally decades. And now we're getting to the current day, SQL Server 2022. So 2022, we have many things we will not discuss. Intelligent query processing updates. There's a whole slew of them, as you can see on one of these directions. Maybe like there. It took me about 5 different tries. I can do things in 3 dimensions and reversed. Ledger tables, don't really care. Purview and Synapse integration, too expensive. Managed instance link, kind of doesn't work yet. Poly-based to APIs, that's pretty cool. But again, we're not talking about that. What are we talking about? Let's find out together. Let me come back down here to back to Earth and jump into this script for 2022. First thing I'm going to talk about, greatest and least. In other languages, this is known as argmin and argmax, where argmin is the least and argmax is the greatest. I don't have a great example here. I actually need to come up with a better demo. But the idea here would be greatest, if I have multiple columns, greatest would be the largest value of whatever set of columns. Least would be the smallest value of whatever set of columns. So if I have let's say I've got 10 trials of some operation, and I have them in a not ideal format. So I've got like a row and then trial 1, trial 2, trial 3, trial 4, trial 5 as columns. I could use greatest for the different trials in order to find which one was largest, and then least to find which one was smallest. It's not incredibly common that you'll do this, but it happens just often enough that it's nice to have this the capability. Second thing, string split. One of the complaints that we had in 2016 with string split was, like I mentioned, there's no way for me to maintain this order, to guarantee the ordering, and especially if I joined to another table. But as of 2022, we have an extra optional parameter. If you set it to 1, then what you're going to get is an ordinal value for each of these columns. So now I can sort it by ordinal value, the ordinal, and that'll give me the ability to ensure that no matter what I do as an intermediary step, I can still return this in the same results of our string input. So that solved one of the problems that people had with string split. People still have some complaints about string split, but I think this is a quite worthwhile function, especially in 2022. Another thing that came out, this actually came out of Azure SQL Edge, which was the IoT SQL Server product. That product is kind of moribund at this point, unfortunately. But one of the major use cases in IoT is time series analysis, is tracking things over time. And to this end, there are several database products that are explicitly time series databases. Think about things like InfluxDB. SQL Server technically is not a time series database, but it does have enough capabilities to give you much of what we would want from time series. And date bucket is one of these capabilities. So if I have the start of the year, so date bucket year, and I have the whatever date I have, so this is December 1, give me the year of this particular value. It's going to be January 1. So I can get the number of orders by month and year. In this case, I've got sales.orders. I'm cross-applying the year of order date and the month of order date. So this is a neat use of cross-apply to give me order year and month. And that'll give me order year, order month, and number of orders for each of those. So we've got this information. The next thing that I want to do is a date bucket version. So now I'm going to cross-apply values, give me the date bucket on a monthly basis based on the order date. And I can get the year and the month of the bucket and the count of orders. So in that scenario, instead of having year and month be separate columns, I can have the year month bucket as a particular date. And I could just show year month bucket itself. So if I rephrase this query ever so slightly. Instead of showing order year and order month to replicate the behavior that I had in the first query, I could just run it like this and we'll see an actual date and then the number of orders. So, that is a possibility as well. Number of orders by week, where we say the week starts on a Sunday. Now, to do that, our starting point here is the date 1900 January 7th. Why is that? That's because that is the first Sunday that has ever existed in the world. Remember, the world started January 1st of 1900, which happened to be a Saturday. So we have our date diff between the first Sunday in the beginning of time and our first Sunday here. It's a lot of parentheses. There's a lot going on. If I explain this to a developer, they're going to get a little confused, but I do have, these are actual Sundays, and I do have numbers of orders over a week frame starting on a Sunday. But again, I have a date add, I have a date diff, I'm doing some casting. It's a little confusing. It's not easy to read. But with the date bucket version, instead of date add, date diff, I say date bucket, weeks, and then here's my order date, and we're going to start in the first Sunday of history. So start on Sundays. Give me buckets for a given week. And what we have here is all of our Sundays in our data set. And we have the number of orders for a week beginning with a Sunday, ending right before the next Sunday. And I would argue this version is a little bit easier to read than this version. They will give you the same results, but one is more maintainable. Date trunk. This is something that has been in Postgres. If I remember right, it's been in Oracle, MySQL for quite some time. And this is kind of going back to our first example of casting as a date. This is a much more powerful variant of it. We've got a table with some customer IDs, and we've got some dates and times. And if I wanted to say, show me, for example, the number of records per customer per hour, I can do that. I could say date add hour, date diff hour 0, and that's create date rounded to the hour. But I have to do that twice. It's not trivial to understand. It does give me the correct results. However, if I use date trunk, I can say date trunk to the hour. So truncate this data to the hour. Same results, not even different data type. It's the same data type and all, but a little bit easier to read. So date trunk, pretty useful function in T-SQL. Has been useful in other variants of SQL in the past before. Now, date trunk will also support other timeframes, hour, minute, millisecond, month. Doesn't really matter that much. If it's one of the officially supported time segments, then we can use it. Generate series. So I mentioned tally tables, and generate series will allow us to build a tally table on the fly. A tally table, literally just a sequence of numbers. But generate series doesn't just build you records one at a time. You can also build it in fives. So if I generate series 1 to 100 by fives, we add 5 and we go until we get to 100, but not above. So we stop at 96. I can go backwards, 96 to 71 by -5. So we see our results here. I can work with decimals, 0.3 to 14.9 by intervals of 0.6. And you can see that we do go up. We stop right before we get to 14.9. Does generate series do dates? It does not. It is numeric, as I recall. But let me pull that up and just make sure. In the meantime, make sure that it doesn't fail on a simple case, like go from 96 to 71 by 5. We get no results. So you can't go to a lower number if you're incrementing. If you try to increment by zeros, you actually get an error. A little bit inconsistent behavior in that respect, but it does at least give you an error message that makes sense. So if I look at the generate series documentation in Microsoft Learn, you'll notice SQL Server 2022, so first version that's supported, generates a series of numbers within a given interval. And so the T-SQL syntax, start, stop, step, but it does define that it is a variable, literal, or a scalar expression of type int, tiny int, small int, big int, decimal, or numeric. So no, does not support date types. You could convert those to dates. You could have, your starting point and then add that many days from your starting point. That would work as well. So if I were to gen something up, let's code on the fly. What could possibly go wrong? Let me double check what the output name is. Value. Okay. Day. We're going to add value days from, let's say, 2813. So you can see that it will, we can easily get the date ranges here if we wanted to do it that way. All right. Windows. Window functions. Whole bunch of window functions came out in 2012. One ordered set function came out in 2017. In 2022, we have this definition of a window. So here's my, again, example of a window function. This was a running total for sales order details, and it gives us a running tally of this line total. And then it resets with a new order. But maybe I have more than just one window, more than one window function, more than one thing I'm interested in. When we looked at the 2012 example, if I scroll back here, remember we had like all kinds of lags and leads. So we had 6 separate windows over here. In 2022, here's a whole bunch of analytical functions over basically the same window. I have the sum, partition by order ID, order by product ID, rows unbounded proceeding to current row. I have the average over the same window. Well, not quite, because this is rows between 2 preceding and current rows. This is a moving average of a 3-month period or a 3 order period. Minimum 2 preceding and current row. Maximum 2 preceding and current row. Standard deviation 2 preceding and current row. So what we have here are actually 2 separate windows. One that is the frame size 3, and the other that is a running total. And this can be a little challenging to maintain because a developer who needs to make a change, maybe we're changing moving average 3 to 4. So we have to change all these 2s to 3s. And I may copy, paste, and I forgot one of them, which happens a lot. So I can run this right now just to confirm. Query gives me results. I don't really care what the results are. I'm not going to move my head for that. But what I do care about is the maintainability of this code. And that's where the window clause comes in. The window clause says I can define M3 as a 3-month operation. Partition by order ID, order by product ID, rows between 2 preceding and current row. Technically, these aren't months. I know I said month, but moving 3 away. And then rows to now. Partition by order ID, order by product ID, rows between unbounded preceding and current row. So I can define 2 separate windows here, and then I can call over rows to now over M3. So now if I want to change M3 to be like M4, that would be a good reason not to call this M3, but I make one change and everything works. So M3 gives me these results that, by the way, are exactly the same as what we had before. M4 gives me slightly different results. Specifics don't really matter that much, but that is a quick change that will be consistent. There is no performance difference. This will not perform quicker. It also will not perform slower. So it is just for the developer to make their lives easier. Next, last observation carried forward, or Windows respecting and ignoring null. Here is a lag operation. We have sales.orders. I'm lagging the prior ship date, order by order ID. If I run through this, what I have here is sometimes the prior shipped date is null. Maybe it hasn't shipped. So we have one order that has not shipped yet. What if I wanted to carry the prior value forward? So I wanted to take this and move it up. So if we have any nulls, I want to fill them in with the last non-null value. That is what we can do with this operation, ignore nulls. So our window, we ignore nulls over order by ID as prior actual shipped date. And if I run this, I will fill in any null values or any null missing values with the last known value in my operation. Very useful for analytical work where I may have samples of data. I collect samples, and some of the samples I don't have a result because it hasn't changed. So maybe I'm only capturing changes. And so I may want to take the prior value and then move it forward, carry it forward, assuming that either it has not changed or it has not changed enough for it to substantially alter the process, but it will not cause my next operation to fail because, oh, well, you have a null in here. So this is a good way to eliminate nulls when performing analytical operations. So we can ignore nulls. We can also respect nulls. As I recall, I'm putting respect in lowercase here because I do not respect null. Respect nulls is the default. So that means it'll keep the nulls in, but I do not respect nulls at all. I despise null. So I will ignore them and hope that they go away. Supported functions on this are our 4 lag and lead, first value, last value. So these are the 4 window functions that support ignore nulls. I talked a little bit about approximate count distinct and how it uses an algorithm known as hyperlog. Guaranteed to be within about 2.3% percentage points of the actual value. In SQL Server 2022, we also have approximate percentile continuous and approximate percentile discrete. These are in the style of ordered set functions. So let me take a step back. We had in SQL Server 2012 percentile continuous, percentile discrete. They were a couple of the percentile or statistical window functions. They also happened to be incredibly slow, as in once you get past maybe hundreds of thousands of rows, performance tanks. Millions of rows, awful. Tens of millions of rows, forget about it. Hundreds of millions of rows may not finish. We're talking about could last hours for a query to finish once you get up to hundreds of millions or billions of rows. Just not feasible. And that's a shame because in a database, it would be great to get like a 5-number summary. By that, what I mean is 25th percentile, 50th percentile, 75th percentile, minimum value, maximum value. That's your classic 5-number summary. Well, if you use percentile continuous or percentile discrete, you were not going to get that on a large, you're not going to get good results on a large data set. It's just way too slow. Approximate percentiles are valid to under 5% error. So there will likely be some error, but the performance is for a few million rows, it's about 2 orders of magnitude faster. So something that may have taken like 150 seconds, something that may have taken almost 3 minutes, would take more like 10 to 12 seconds. This is a very small table, so it's going to return basically immediately. But we can see 25th percentile, 50th percentile, 75th percentile, 95th percentile, 99th percentile. The exact numbers don't matter that much. You're within a few percentage points. And again, for the type of statistical analysis that is off of a large number of rows, if I tell you that your 95th percentile response time for an API is 209 milliseconds, and the real number is actually 218 milliseconds. That doesn't really matter much unless you have a hard SLA that says 215 milliseconds and you pay back the company money, which is very rare. So to get a feeling for where this is within a few percentage points. So if the number here is 209, we would expect, or we can guarantee that the real value is 209 plus or minus 5%, thereabout. I think it's like 4.6%, 4.7%, somewhere around there. But roughly within 5% of 209. So basically think of that as about 200 to 220. And if I tell you that's milliseconds and this is response time for an API, you can say, oh, okay, 220 milliseconds or 200 to 220. Do I need to improve anything? Is that acceptable? And the 99th percentile might be, 350 to 385. As this number goes up, obviously the range goes up because you're talking about 5 percentage points. But general idea here being that we can give a reasonable analysis at an appropriate level of concreteness without overly taxing the database. If I had a million rows in here and I tried to run percentile continuous, not the approx, but percentile continuous on this, I am not joking. It would actually be faster to install SQL Server machine learning services, learn how to set up R or Python, learn how to perform a 5-number summary, write the code to perform a 5-number summary, send that code into R or Python, have it process the results, have those results come back to you in a result set, would still be faster than running the percentile continuous once you get up to like 10 million rows. Literally would be faster to do all of those steps. So approximate percentiles, really helpful. Now, this is a different behavior. Percentile continuous and percentile discrete in SQL Server 2008 were window functions. These are ordered set functions. They have a within group operation. So they are aggregation functions, which means that I need to group by employee ID. With the original 2012 versions, we did not group. It was a proper window function. And I think that was actually part of the performance problem. I don't know that for sure, but given that behavior has changed, I'm going to guess that's part of the issue. Okay. Moving on to demo 8. Is not distinct from. Again, I am not a respecter of nulls. We have our data here in sales.orders. We are going to say where employee ID is equal to 6, and we see some data. We have some shipped dates. Some of them are missing. We have required dates. We have customer IDs. Let us suppose that I want to think about things that were shipped on April 24th of 2022. I can write this query. I declare a variable, and I can say where employee ID is 6 and shipped date is equal to my input shipped date. If I run this query, I will get back 2 results. The 2 records that were shipped on April 24th. Now, I then want the converse. I want everything that is outside of that set. Actually, even before that, apparently what I want is, let's say null. So declare this date equal to null. And we say where ship date equals input ship date. We see no records, even though I did show you there are 2 records that have null shipped date. The reason for this is null equal to null? No. Because we don't know what null is, so we don't even know that null is equal to null. And for that reason, I cannot use this syntax for my query and send in null. Instead, I have to say, and ship date is equal to input ship date, or ship date is null and my input variable is null. Now, this gives me back 2 rows. It works, but does not perform as well. Once you have large data sets, once you have variety in terms of input parameters, you can have parameterization problems. You can have query performance problems, especially as your queries get more complex. It's more than just a scan of a table, and it's more of joining to a series of tables and performing other operations based on the value or lack of value. Now we can decomplicate things. I can say declare input ship date 2022-04-24 and say ship date is not distinct from input shipped date. And I can run this query and I get back 2 results. I could also say set it to null. So input ship date is null. Well, if shipped date is not distinct from input shipped date, I will get back null. So what is not distinct from is it's checking, are you equal or are you both null? So it's doing the equivalent of this operation, which, by the way, means it will not perform better. It's not a performance improvement, but it is a simplification in concept because I no longer need to have this explicit check or run the risk that somebody sends in null where we expected them to send a value and they get back no results. If I set this null, I say is distinct from. So we have is not distinct from, and we have is distinct from. So is distinct from April 24th of 2022. We will get back everything else, including nulls. Is distinct from null. We will get back everything that is not null. All right. We have gone through a lot of examples and are actually wrapping up now. So the T-SQL language has changed a lot in the past slightly more than a decade at this point. But between new functionality, enhancements to the existing core language, there are, I think, plenty of opportunities to take your existing code without having to add in new functionality or features and make that code base better. Maybe clean up some of the operations that in the past might have been written a different way, that you had to write it that way simply because that was the only option available to you, but that today there is a better way. If you would like to learn more, I have these slides, I have the demos, I have links to additional resources. It is all at csmore.info/on/olddogs. If you have any questions afterwards, please do feel free to send me an email, or you can hit me up on X, or you can actually reach me on Meetup. And with that, you know what? Since I've got time, hey, thank you, Mark. Oh, let me say meetup.com/trypass, which is the official meetup of the Triangle Area SQL Server users group. Got a couple of upcoming events. This was tonight. You're right here, right now. Next Tuesday, we have Getting Started with Governance for Power BI Estate by Angela Henry. So Angela's going to come into town. This one will be in person, so please stop in. And then 2 weeks from today, we have How to Weave Data Ops into Microsoft Fabric by John Kursky. The day before, on the 26th, we will have our next episode of Shop Talk. So with that, I want to say, everybody, until we see each other in a future TriPass meeting, take care.